Welcome to this channel. In this video, we are going to discuss some questions, some important questions based on the chapter acid, bases, salts. So the first question I've taken is, you have to name the acids present in tomato, vinegar, and tamarind. Now, the acid present in tomato is oxalic acid. And in vinegar, it is acetic acid. In tamarind, it is tartaric acid. So these are the acids present in tomato, vinegar, and tamarind. The next question is says 5 ml of water and 10 ml of sulfuric acid are to be mixed in a beaker. And the question says that state the method we should use or follow with reason. And we also have to name the process. So it's a very important that recommendations that water should never be added to acid, because the reaction with water and acid is highly exothermic. So what are the possibilities that if you are adding water to acid, since it is an exothermic reaction, the heat so produced can be so large that it can either burst the container or can spill and cause a severe burn to the person performing this. Now, so we need to be very careful that acid should never be added, right? Water should never be added to acid, because this process of dissolving is highly exothermic. Instead, we should add acid to water, and that also drop by drop, and continuously stirring it so that the heat so generated escapes slowly. And this is one important thing, that because if you mix water, the heat so produced, if you mix water on acid, the heat generated is so large that it can splash out also. So that's what the recommendation. So the cause is now understood to you, that method we will add, we will do what? We will take 5 ml of 15 ml of water and say 10 ml of acid, and then we will add acid on water, and that also drop by drop, and then we will stir it so that the heat that is released during this process, as it is an exothermic process, escapes and the internal heat does not increases. Now, further, what is this process? That this is a process of dissolving and mixing water with acid. This process is known as dilution. So the process of decreasing the concentration of H plus ions or strength of an acid is called dilution. In the next question, we have to define olfactory indicators, and you have to name some substances which are used as an olfactory indicator. So you should know what are olfactory indicators. These are substances which have different odor in acid and base. So olfactory indicators are those which either retain their smell or changes the smell when it is put into an acid or base. And we have one more where we have to give examples, right? Name two substances which are used as an olfactory indicators. We have three I've taken. These are onion, vanilla essence, and cloves. So these are three olfactory indicators. In case of onion, in acidic solution, it has a characteristic smell, and in case of a base, it has no smell. That means it loses its smell, you can say that. In case of with vanilla essence, in base, it retains this smell, and in acid, it has no smell. Similarly, for clove is the another olfactory indicators. In this case, the smell is retained, like whatever is the smell of clove, it retains the smell, but it loses its smell in basic solution. I can see that there is one extended question where we have to also figure out which of them are strong acid. Well, acetic acid is what? This is CH3COOH. Common name is acetic acid, and its chemical name is ethanoic acid. This is a weak base, which is 5 to 8% of this is used in vinegar. Like vinegar is nothing but 5 to 8% of acetic acid. So it's very obvious that it must be, since we are consuming, it must be a weak acid and it's an organic one. Then we have sulfuric acid. Yes, it is clearly a strong acid. This is H2CO3, that is carbonic acid. Carbonic acid is there in the soda water, the water or soda water, or maybe the Coke, Pepsi, and all aerated drinks have this. So this is again a weak acid, while HNO3 is a mineral acid and it is a strong acid. So we'll say that we have to select the strong acid. So we'll say it is sulfuric acid and nitric acid are strong. Now we should know why we say that is strong. The reason is that, let me just figure out. This is sulfuric acid and this is nitric acid. So they completely ionize. When it is dissolved in water, they completely ionize. And that is the reason. So we say that it completely ionizes. That means it all the acid ionizes to H plus ions. But the other acids like say acetic acid or nitric acid, they partially get ionized, not completely, and that's why we call them as weak acid. In the next question, he says there is a white colored powder is used by doctors for supporting fractured bones. So you should know that plaster of Paris is used by doctors for supporting bones as it becomes hard on mixing with water. So this POP is chemically named as calcium sulfate hemihydrate. Well, that is what the next question. It says, write a chemical name and formula of the powder. So the powder's chemical name is calcium sulfate hemihydrate. That's its chemical name. And the chemical formula is CaSO4 dot half H2O. This is half water molecules is attached to this. Now, the further next question as we proceed to the same, it says, when this white powder is mixed with water, a hard solid mass is obtained. So we have to figure out what is that substance. So clearly, when calcium sulfate hemihydrate, that is POP, is mixed with water, it absorbs 1.5 water molecules and turns into calcium sulfate dihydrate, and this is gypsum. This is gypsum. So we are also asked to write down the chemical equations for such a change. So if I write down the chemical equation, yeah, so it's going to be, this is POP, CaSO4 dot half H2O. Now it is mixed with water, so then it will absorb 1.5 water molecules and turns into gypsum, that is CaSO4 dot 2H2O. Chemically, this is calcium sulfate di stands for two water molecules. That's why it's called calcium sulfate dihydrate. So this is what the reaction so involved, or you can say this is a balanced reaction. The next question says, explain how antacid work. Well, you know that our stomach produces hydrochloric acid, and that is needed for Pepsi to work upon. That means it is required for the digestion of food, not directly, but it has an important role in the digestion of food. But when this acid is produced in the stomach, right, when it is, as you know, this our stomach produces HCl, hydrochloric acid, and that helps in the digestion. But during indigestion, what happens? The stomach produces more acid and it causes pain and irritation in our abdomen. And to get the relief from this, what we get, we take a kind of medicine that is called antacids. So the antacid is what? This is nothing but a mild base, right? And let's understand why we use this mild base. As you know that an acid, when reacts with base, and it becomes salt and water. So that means acid as well as base, they loses their acidic and basic character. If not loses, they decreases their acidic strength and basic strength, and a neutralization takes place where the neutral substance is formed. So now this is the reason why we use a mild base to get a relief from the pain. So this mild base, which we use to get a relief from the pain or the irritation caused by excess acid in the stomach or acidity, is called antacid. Well, commonly used antacid is milk of magnesia, that is nothing but magnesium hydroxide. This is a mild base and therefore it helps in neutralizing the excess acid produced in the stomach. Well, there is another uh, antacid which is used is baking powder. Now, baking powder, that is NaHCO3, this is a basic salt. This is not base, we can say, but it is a basic salt and it is mild. And that's the reason why it also can be used as an antacid and can be consumed. And as I said, it helps in getting relief from the excess acid produced in the stomach or relief from the pain or irritation caused by excess acid produced in the stomach. This is what an antacid. The next question is here. It says, explain the action of dilute hydrochloric acid on the following. And we also have to write down the chemical equation. Chemical equation involved. Or the chemical, that's what. Now, the question first is when dilute hydrochloric is added with magnesium ribbon. Well, magnesium is a metal and we know that an acid reacts with metal to give salt and hydrogen gas. So the magnesium is what? This is Mg. It reacts with dilute hydrochloric acid. So obviously salt and water will be produced. The salt here is magnesium chloride, NgCl2, plus hydrogen gas is released. Well, this hydrogen gas so released during the reaction, right, we can test the presence of this gas by bringing a burning splinter near it. The next is sodium hydroxide. Well, sodium hydroxide is a base and magnesium when react. You should know that base also reacts with what we have to do, dilute hydrochloric acid. Fine, dilute hydrochloric acid with sodium hydroxide. So I'm doing the next part here. That means here I'm doing this sodium hydroxide. So magnesium is not what magnesium is done, right? So we need to react dilute hydrochloric acid. Well, and and sodium hydroxide clearly is a strong base. So you should know that when an acid reacts with a base to form salt and water, that's called neutralization reaction. I'll show you the reaction here. Yeah, so here is the reaction of an acid with base. So you should know that an acid reacts with base to give salt and water. So this reaction is called neutralization reaction, where both acid and bases lowers their strength and a neutral substance is generally formed. So you can see the reaction is already written here. That is sodium hydroxide is a strong base. When it reacts with an acid, it will give a salt. Sodium chloride is which we know is that as a common salt and water is produced. Now coming to the next part. Then we are on the third part where we have to react the dilute hydrochloric acid here with crushed shell egg. Well, crushed shell egg is calcium carbonate, CaCO3. Well, this is common in this calcium carbonate where there's a limestone, marble, chalk. They all have calcium carbonate, which is nothing but a metal carbonate. Generally, we can call it as a metal carbonate here. So you should know that whether it's a metal carbonate or metal bicarbonate. So acid reacts with both metal carbonate as well as metal bicarbonate to give salt, water, and carbon dioxide. So this is what the general reaction, and now we can write it. That is, as I said, acid here is hydrochloric acid, that is HCl. If it reacts with calcium carbonate, I said calcium carbonate? Because crushed shell egg is calcium carbonate. it reacts to give as the salt. The salt clearly has to be here CaCl2 from calcium and chlorine and carbon dioxide plus water. Well, carbon dioxide is a colorless and odorless gas, and we can detect its presence, right? We have a test here, the carbon dioxide gas. Well, I'm extending it that we can detect the presence of carbon dioxide. We have a test for this. Carbon dioxide gas, when passed to the freshly prepared lime water, the lime water turns milky as it forms precipitate of calcium carbonate. So now we get to know that crust shell egg is calcium carbonate and which is a metal carbonate, and metal carbonate when react with acid to give salt, carbon dioxide and water. So these are the product formed in this case. Now, there are 5 subparts in this question. It says, state the reason for the following statement. The first one is tap water conducts electricity while distilled water does not. You know that distilled water, which we know as a purest form of water, is a poor conductor of electricity. But the tap water have minerals dissolved. The minerals in the form of salt could be Mg plus, calcium, Ca2 plus. Sorry, this is also 2 plus. So these salts in the form of an ions are responsible for conduction of electricity. Moving to the next, it says dry hydrogen chloride gas does not turn blue litmus red, whereas dilute hydrochloric acid does. So it's very important to know that acid shows the presence of H plus ions, right, in the presence of water. That means an acid will show its acidic property only when it is dissolved in water. But the first thing that you should know that all acids have something in common. That is, they all have H plus AQ, or you may write H3O plus, that is hydronium ions. So this is the H plus ions, or the ions are responsible for the acidic character of any substance. So since dry hydrochloric acid gas, its chemical composition is same, that is HCl only. But since it is in the gaseous form, it will not show its acidic strength unless it is dissolved in water. But as we dissolve in water, it shows its acidic strength. And that's why it started showing its acidic properties and it turns red litmus blue. Now, the next question is says that during summer, the milkman usually added small amount of baking soda, right? Baking soda is a mild base, right? So the pH of a milk is around 6, so it is a possibility that it will get spoiled very easily. Adding baking soda to this milk whose pH is 6, actually it shifts its pH to higher than 6, maybe 6.5 to 7. So this actually, we can say that delay the spoilage of milk, because baking soda is a mild base, and you know that the in milk there is a lactic acid present, so it actually helps in neutralizing, or we can say it shift the pH higher so as to delay the formation of curd, or maybe delay the formation of prevent the spoilage of milk. For the next part, we have already done this thing. That is, in this, we should never add while dissolving an acid, right, or diluting an acid. It's important that we should never add water to acid because adding water to an acid can cause burn, because this is a highly exothermic reaction. And during this, the heat so produced, it can splash and can cause severe burn to the person performing this. And that's what's the reason why we should not. Instead, we should add acid on water, and that also drop by drop, right? This way, excess heat will escape, and we need to continuously stir it. The next is, we know that all bases have one thing common, and what is that? Hydroxide ion is common, right? Let me come down to the same thing. Yeah, that's all acids have H plus ions common, and all bases has OH minus ions common. So that means if we dissolve all bases, all bases has OH minus ions common. So if we dissolve ammonia, right? So it says ammonia is a base but does not contain hydroxyl group. Like ammonia is in the gaseous form is NH3, and but it does not have hydroxyl ions. Yes, that's true. But when it is dissolved in water, right, it gives ammonium hydroxide, right? Further, on dilution, it will release OH minus ions, that is hydroxyl ions, right? Then hydroxyl, sorry, it is hydronium ions for H plus, and this is hydroxide, right? Hydroxide ions. Yeah, I think I was right. And that's the reason why we say, although it does not, ammonia does not contain hydroxyl group, that means this does not contain OH minus, right? So this does not contain OH minus, but when dissolved in water, it turns into NH4OH, and on further dilution, it produces OH minus ions, and therefore we say it's a basic in nature.